We go on to quiz 1, question 2. We're still with the quiz 1 solutions. So I'm being told to find dy by dx, where we have the function x y squared is equal to tan inverse of y. So now this one is an implicit function because it's not on an equal sign. We don't have only one variable. For example, if we only had y this side, we could say it's not implicit, but then it has both functions. It has both variables on each side, and there's nothing like one which is subject of the formula. So if one function is subject to the formula and then it's not on the other side of the equal sign, we can say it's an explicit function. But then in this case we have ourselves an implicit function. Then I'm going to show you how we go about implicit functions. So we differentiate both sides with respect to whatever we have. So we have d over dx of x minus y squared is equal to d over dx of tan inverse of y. So now we have ourselves this one. So here we can use the sum and difference rule, where we say dx over dx, this x is this one, minus dx d of x over y squared is equal to so now how implicit differentiation comes in: when you're differentiating a certain variable or a certain expression with respect to another variable that's not in that expression, you're going to differentiate this one with the variable that's in the expression, say d over dy of tan inverse of y. But then what you're going to do is at the end you're going to say dy, the variable that you put there, over dx, the variable that you're going to remove. So let's say you're differentiating maybe something like d over dt of maybe 2z, right? You're going to say this one will be equal to d over dz of 2z, but then you're going to say dt over, you're going to say dz over dt, so that this z and this z can cancel out and you can still get back to whatever you have there. So that's this that we have ourselves here. So now dx with respect to x is just 1, or you can just cancel them out and then remain with the 1. Then this one we're going to do the same thing, implicit differentiation, dy of y squared dy by dx, which is equal to the derivative of tan inverse of y is just 1 over 1 plus y squared. I went over the derivative of inverse trig functions dot dy over dx. And then you're going to put the dx and dy and dx at the end of the expression, so that at least you don't confuse yourself, because if you put them before the expression, you're going to think as if you're trying to differentiate it. For example, this one is operating on this one, and then this one is just there implicitly. So I'm going to have 1, this one is 2y dot dy by dx is equal to 1 over 1 plus y squared dot dy by dx. So then what we're going to do here is we're going to collect the like terms, so that we have the like terms in terms of dy and dx, so that we can make it subject to the formula. So when we take this one that side, we're going to have 1 equal to 1 over 1 plus y squared dy by dx plus 2y dy by dx. So then we factor out whatever is common. So whatever is common is dy over dx. So I have 1 over 1 plus y squared plus 2y dy by dx. So you've seen how I've put the dy by dx this side, because if I put it this side, I can treat it as this one and then differentiate again. So to make dy by dx subject, we're going to divide both sides by 1 plus 2y over, like that, 1 over 1 plus y squared plus 2y. So then this one and this one will cancel out. Then here we're going to have 1 over 1 plus y squared plus 2y being equal to dy by dx. So then dy by dx will be equal to 1 over, when you add this one, you're going to have the common denominator to be 1 plus y squared, where this 2y is over 1. So 1 plus y squared into 1 plus y squared is simply 1. 1 plus 1 into y plus 1 squared is just 1 plus y squared. So we are going to multiply it by a 2y. So we're going to have 1 plus y squared. Then since this is in the denominator, you can push it to the numerator, dy by dx being equal to y plus 1 squared over, this one will be 1 plus 2y. When you multiply 2y times 1, then 2y times 2y squared is 2y to the power 3. Then we're being told to find the value of dy by dx at y is equal to 1. So wherever there is y, we're going to put a 1. So dy by dx is equal to 1 plus 1 squared over 1 plus 2, 1 plus 2, 1 to the power 3. So dy by dx is equal to, this one will simply be 1 plus 1, which is 2. This one will be 1 plus 2 plus 4, 1 plus 2 plus 2, which will be 5. So we found the value of this one.